You're not really doing something very revolutionary if you're not running into some dead ends. Yeah, things could work out differently. If I started the same thing again, it might turn out different from the paths I've gone down.
My name is Devon, and I'm a software engineer. Today, we're going to talk to Andy Hertzfeld, an engineer on the team that built the original Macintosh. The Mac transformed the way we interact with computers. It was the first successful PC with a mouse and graphical interface, and its 1984 unveiling set the standard for personal computing ever since.
You don't have a clear idea of what it's going to be when you start. You have an inkling, and then each step tells you what the next step is, but you don't know what the next step is until you've gotten to a certain point.
We've all seen the legendary Apple keynotes and how computers have transformed the way we live and work. But what I was really interested to learn from Andy was what it was like to shape that vision from scratch.
There were a few other people like that who would just hang out in the store all day Saturday to gape at the Apple II. And so those people became the people who started the first users group. I knew them because I, too, was one of the people transfixed by it at the store. And so one of the times I was at the store, someone handed me a little notice, hey, we're starting a users group. It was even more important, actually, once you had one, to go meet with other people to exchange programs and hear the latest rumors. I was up like almost all night the day before, just polishing up whatever programs I had written that month, all to give away to the club. There was no commercial market at all. It wasn't even well understood that anyone would pay for personal computer software. So it was all just totally driven by enthusiasm and then just giving it away.
So how did you originally get involved in the group?
Even before I couldn't afford to buy the Apple II when I had fallen in love with it at the first West Coast Computer Fair, which is where it debuted. But its price, which was $17.95 for only a 4K Apple II, just out of my price range, more money than I had. But then in January 1978, they lowered the price by $400. They said they were only for 1 month. That brought it down just below the amount I had in the bank. So I was able to pay it. But before I could afford to get the Apple II, I used to go on Saturdays to the computer store and just stare at it and watch other people, maybe a little more affluent than me, buy it.
The Apple II enchanted a generation of hackers. In 1977, Byte magazine wrote that it was the first product to fully qualify as the appliance computer, a completed system which is purchased off the retail shelf, plugged in, and used. A year later, Apple began work on the Lisa. The team introduced a new paradigm based on ideas from Xerox PARC, the mouse-driven graphical interface.
The problem with the Lisa was it was going to be very expensive compared to the Apple II. It ended up costing $10,000 originally, and that's in 1983 dollars. So that would be more like $40,000-$50,000 today. That's not a computer for the masses. Whereas we were really inspired by the Apple II, which was affordable to an individual.
The Lisa was lauded for its innovative design, but it was a commercial failure. Steve Jobs was kicked off the Lisa and onto a smaller project, the Macintosh. What were some of the key ideas that you guys took from Apple II, and what things did you guys end up changing?
The Macintosh was kind of a marriage between the Apple II on one hand and the Lisa on the other hand. So my job was really to take the brilliant work that Bill did for the $10,000 computer and try to get that to fly in a $2,000 computer. The Macintosh was taking the accessibility and user interface of the Lisa and the price and the hacker spirit of the Apple II and mushing them together. You could say the Macintosh was the people's Lisa, just this very, very clear goal of take the Lisa $10,000 computer and make it into a $1,500 computer.
What were some of the things that you did to get this amazing software and hardware to fit into that price range?
So we got rid of the Pascal because you could make things 3 times more efficient if you hand code them in assembly language. The other thing is the hardware design of the Macintosh was orders of magnitude more clever than the Lisa. The Lisa used more or less industry standard techniques, whereas Burl Smith, the hardware designer of the Macintosh, was inspired by Woz and used crazy tricks all over the place. Lisa didn't have that Apple II magic feeling about it. It was done by a large team with a more formal process. It wasn't really a hacker's machine. The central thing, though, is Lisa wasn't really viewed to be a platform for third parties. Because of our experience with the Apple II, where third parties, people who didn't work at Apple, did some of the coolest stuff for it, we wanted that for the Mac. And so from the very beginning, we conceived the Macintosh as an open software platform, and we invested a fair bit of effort in recruiting third parties and supporting them. The Macintosh just had all this love poured into it, and that was a pretty big difference.
The story that is usually told about influential creators is that they had a predestined vision. But from talking to Andy, it's clear that it felt very different from the inside. The team didn't know what the Macintosh would become.
Well, it was really development through prototyping. We didn't really trust ideas on paper. Our philosophy was really incremental development. As I was saying before, each step tells you the next step to do. So that was, you would call that an agile programming style in today's parlance, although that was like decades before that terminology was created. What we didn't know with the Macintosh, and what I wish we did, we could have done a better job, is we didn't have enough sense of it as a durable platform. We thought we were making an exquisite product, the best possible thing at the time, but then we figured, well, in a few years we'd make something a lot better, completely different. We didn't realize the architecture we were putting in place could last 5 years, let alone 10, 20, 30 years. We thought that just as if we loved the Apple II, but we were replacing the Apple II with the Macintosh. It came out 7 years later. We were trying to do it about 5 years later. And so we thought something would come along again in 5 years and just totally obsolete the Macintosh. But that was a misunderstanding. That's not the way it worked out. What we would have done differently was, instead of madly optimizing like we were to the particular hardware, we would have made it sort of stronger foundationally, more industrial strength underpinnings, really. We were creating a platform, but we weren't really aware of it at the time.
I expect to be totally amazed at what people are going to do with Macintosh, and I expect people to use Macintoshes to totally blow my mind.
The most important ideas for making the Macintosh a delight came from close attention to detail rather than some overarching vision.
I don't know about insights, but lots of little discoveries we made to improve the software, like what's called mouse scaling. Typically, the naive way to implement the mouse is every little notch that you move would move 1 pixel. But if you really do things that way, it's very sluggish to move the cursor to get from the top of the bottom. So we eventually stumbled on the idea of putting in an acceleration factor. The more quickly you move it between the pixels, the more pixels it goes. But we didn't have that for the first year. You could turn off the mouse scaling or adjust it so you could see how frustrating it used to be before we came up with that. I think just the essential way to do anything great, you have to have some kind of incremental development philosophy, because you're going to just be wrong with your grand design that you don't iterate on.
By the 1990s, Andy was asking the question, where do we go after the personal computer? He and several colleagues from Apple co-founded a company called General Magic, where they developed a new kind of handheld device.
Where we were right on was just the concept of a pocket communicator. It's obvious looking around the world today, that's what people want and need. I mean, just this idea that communications was as important or more important than computation. in 1990, that was not a mainstream idea. We were like laser focused on making a communicator. The idea was little postcards, little graphical postcards would fall out of the sky into your pocket. That was the founding vision of General Magic. That's really right on. We were working on the iPhone of the 90s.
While General Magic had the right idea and a brilliant team, they didn't have the right timing or execution.
Some of them were just General Magic blunders, like not really choosing the best processor architecture. I mean, again, clearly the ARM chip was the way to go for the portable things, but we weren't using the ARM chip. The personal computer industry was mainly focused on performance and doubling the performance every 18 months, but that doesn't hold for things in your pocket. It's just as important for it to last a long time without a charge.
The team wasn't always right about conceptual, strategic decisions either, but they were always ambitious.
Communication services, especially at the time, were all, this was way pre-web, but they were hard to change and sluggish and maintained by the largest companies, and it was like pulling teeth to get a new feature in. We had the insight, if you just made the basic architecture of the server able to accept arbitrary programs, you can unleash innovation like crazy. So we invented this new programming language called TeleScript, where programs can travel in the network between servers, gathering up what they needed and then coming back to the device. Thought that was a pretty compelling vision. But history proved us wrong. You didn't really need to do that. Just the remote procedure call type paradigm was good enough, which is really what the web is based on. You don't inject code into the web to do your work for you and come back to you. You just ask a server, with an HTTP request. So that was an example where we invested a huge amount of our development resources in creating this new kind of communication infrastructure for intelligent networks. And the world has, that we didn't get it established, and here 25 years later, it's not around, so we must have been wrong. It's kind of a sculptor-like way of working, where if you tried to spec out the final thing, it'll end up not right. Every program I've ever worked on, you don't have a clear idea of what it's going to be when you start. You got to just try different things. Almost always, each step I take tells me what the next step should be.